To review, all chemical reactions must obey the law of conservation of mass. They must be balanced. So in this reaction, it is now balanced because we have 3H2, which is 6H atoms on the reactant side, N2 is 2N atoms on the reactant side, and then 2NH3 would be 2N atoms on the product side and 6H atoms on the product side. This supports the Bohr notion that atoms are simply rearranged in a chemical reaction. They are not created or destroyed. So they're rearranged from the initial materials that we started out with, in this case, hydrogen gas and nitrogen gas, to form a new gas, NH3, that has different properties than the reactants that it was formed from. Nuclear reactions do, quote unquote, destroy atoms, as we'll see in later units, but they do still obey the law of conservation of mass. When you balance a reaction, you only change the coefficients, those numbers in the front, because if you change the subscripts, you're changing the nature of the material itself. So in this example where we're trying to balance H2 plus O2 produces H2O, you can see the oxygens are not balanced. We have 2 on the left and only 1 oxygen on the right. Well, we can't just say, okay, well, let's just make this a singular O, and then it's all balanced. A singular oxygen atom is not what's reacting here. It's molecular oxygen gas O2. So we can't do that, right? Instead, we have to change the number of oxygen and water molecules that react. So if we want only 1 oxygen atom, I can take that O2 molecule and put this 1/2 coefficient in the front, right? So that's a coefficient now, and this is balanced. Now, to completely balance this, we want to make sure our coefficients are whole numbers. So if you multiply this entire thing by 2, you get 2H2, and I'm going to leave the states of matter off for now just to emphasize the coefficients, okay? So 1/2 times 2 is just 1 oxygen and then 2 water molecules. So now this is balanced. There are 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, and 2 oxygens on the right. All right, so as we saw in the previous slide, fractions may be used as coefficients, but then we multiply through by a number to get whole number coefficients. So if we look at this example here, we have a 1/2 O2 again, just like we did on the previous slide. So to get a whole number, multiply all the coefficients by 2. So this 2 times 2 is 4. There's a 1 here times 2 is 2. There's a 1 here times 2 is 2. 1/2 times 2 is 1. 2 times 2 is 4. And 1 times 2 is 2. Okay, so your final reaction should have whole number coefficients. Let's now look at these reactions from a particulate level. There are multiple representations with which we can understand what is happening in our chemistry class. Particulate representation focuses on the particles or molecules of the chemicals, atoms and ions, and their behavior. These could be simple computer animations with solid spheres moving and colliding in a container. So we have our macroscopic view, our submicro or our particulate view, and our symbolic view. Take a closer look at these in the next few slides. Okay, so here are some visual representations of how we might see particulates in class. So in this first one, this is a particulate representation of pure water vapor. It's a gas, right? We can see because the molecules are spread out, don't have much attraction for each other. And you can see the big oxygen in the middle and 2 hydrogens on either side. In B, this is pure oxygen gas, so O2, you can see those O2 molecules. Okay, in C, we have a mixture. See how it's the first two combined together, oxygen and hydrogen. Okay. In D, we have the same as C, but it's a different mixture. Do you see how here we have 3 waters and 2 oxygens? Here we have 3 oxygens and 2 waters, so just a different mixture, okay? In E, we have pure sodium chloride, so solid NaCl. Look how tightly packed those ions are in that crystal lattice structure. And then, of course, what happens when you put that NaCl into water? Those water molecules solvate the ions as they dissociate, and the NaCl dissolves. So you have a homogeneous mixture or a solution of NaCl and liquid water. All right, so shown above is a particulate representation of the reaction that happens when 2 hydrogen molecules react with an oxygen molecule to produce 2 water molecules. The oxygen atoms are represented by white circles, so these are oxygen, 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 and the hydrogen atoms by smaller black circles. So in this case, 2 hydrogen molecules, we need 2 hydrogen molecules to react with 1 oxygen molecule. That's why we have this dashed circle around it. So these will react. And what happens? Remember, in a chemical reaction, the bonds are broken, the atoms rearrange, and they are reformed. And so they reform H2O, H2O, with 2 oxygen molecules in excess. Okay? So as I said, I've outlined the molecules that react, and these sorts of particulate representations allow you to focus on the conservation of the particles rather than the concentration of the container.